Hey everyone, and welcome. Today, we're diving into something I think is absolutely fundamental, the axioms of great code. We're pulling these ideas straight from Chapter 2 of our source text, and they really get to the heart of what separates good code from truly timeless software. Let's jump right in.
Okay, so right off the bat, this might sound a little backward, doesn't it? I mean, we spend so much of our time hunting for bugs, but the core argument here is that duplication is the real villain. Just think about it for a second. When you have the same piece of knowledge in 2, 3, or even 10 different places, a single change means you have to remember to update every single one. And you know what? Inevitably, you're going to miss one. And that's it. That's where the decay begins.
And this leads to a pretty huge shift in mindset. The common view, the one a lot of us start with, is that you build the software and then you maintain it. But the pragmatic view, it's completely different. Maintenance isn't some chore you do later on. No, it's this continuous activity of care and improvement that starts with the very first line of code you write. You're always building for the future.
That's the million-dollar question, isn't it? If we want to avoid that slow, painful decay caused by duplication and just thinking about the short term, what are the rules we need to live by? How do we build systems that are easy to change and easy to understand right from the get-go?
Well, the answer lies in 3 incredibly powerful, almost mathematical principles. These aren't just suggestions or nice ideas. They're axioms, the very foundation of robust, flexible software. Let's break them down.
First up, we have NSR, or Don't Repeat Yourself. You probably heard it called DRY. Now, the really important thing to notice here is the word knowledge, not just code. This is so much bigger than just avoiding copy and paste. We're talking about database schemas, documentation, comments, you name it, anywhere a piece of information lives. The rule is simple. If you have to change something, you should only ever have to change it in one single place, period.
Next, we've got orthogonality. If you remember your geometry class, orthogonal lines meet at a perfect right angle. They're totally independent. It's the exact same idea in software. Changing the user interface shouldn't break the database. Adding a new feature over here shouldn't cause a bug way over there. Orthogonal systems are built from these independent, decoupled components, and that's what makes them incredibly stable and just easier to work with.
And our final axiom is reversibility. Look, the world changes. Your requirements are going to change. Technology definitely changes. A brilliant decision you make today might be a huge liability in 2 years. So reversibility means you design your code so you're not locked in. You build smart abstractions around things like third-party services or databases so that if you ever need to swap one out later, it's a small localized change, not a full-blown rewrite of the whole system.
Okay, so those are the big ideas. But what does all this actually look like in the real world? In practice? Let's check out some concrete examples that you can start applying to your own code, like today.
This is such a great illustration of a dry violation. On the left, you can see the length is stored as a separate piece of data. So what happens if someone moves the start or end point? Boom! The length is now a lie. It's stale data, it's wrong. But the pragmatic design on the right, it's so much smarter. It doesn't store the length at all, it calculates it on demand whenever you ask for it. The length is derived from the true source of knowledge, the start and end points, which means it is physically impossible for it to ever be out of sync.
And this is just a fantastic analogy for what it feels like to work in a non-orthogonal system. If you've ever watched someone try to fly a helicopter, moving one control stick requires all these tiny, constant adjustments on all the others just to keep from spinning out of control. Non-orthogonal code is exactly like that. You try to fix one little thing and suddenly 3 other things you never even touched are broken. It's exhausting and it is incredibly risky.
So here's the bottom line. When you build orthogonal systems, you get 2 massive wins. First, your productivity just skyrockets. You can make changes with confidence, knowing you're not going to cause some crazy domino effect. And second, your risk plummets. A bug in one component stays in that component. It's contained. It doesn't cascade and crash the entire application.
Now, all this stuff is great when you know exactly what you're building. But let's be real. How often does that happen? What do you do when the requirements are foggy and the tech is new? How do you move forward without painting yourself into a corner?
This is where the tracer bullet approach is a game changer. Instead of building your app one big layer at a time, you build one single thin slice that goes through all the layers, from the UI, through the business logic, to the database, and all the way back. That first slice becomes the skeleton of your application. It proves your architecture actually works, and it gives real users something they can touch and interact with from day one, giving you priceless feedback to guide everything else you build.
And it is so important to understand this. Tracer bullets are not the same thing as prototypes. You write tracer bullet code to keep. It's the actual foundation of the final product. A prototype, on the other hand, is totally different. It's built to answer a specific, risky question, and it's designed to be thrown away. With a prototype, the value is in what you learn, not in the code itself.
So, as we start to pull all this together, you can really see that being a pragmatic programmer isn't about following some specific framework or trendy methodology. It's bigger than that. It's about a core philosophy, an attitude that you bring to your work every single day. And really, that's the ultimate takeaway. Great software, the kind that's flexible, stable, and easy to maintain, it doesn't just happen by accident. It's not luck. It is the direct result of consciously and rigorously applying these principles, like DRY, orthogonality, and reversibility, from the very first day of a project right up until the very end. So I'm going to leave you with this final thought, this challenge. Go look at the last piece of code you wrote, the last thing you committed. Can you find just one piece of duplicated knowledge? It could be in a comment, a variable, a function, anywhere. Find it, and then think about how you could apply one of these axioms to make it better, because that is where great software truly begins.